So now let's look at the eukaryotic replication fork. How is it different? And how is it similar? So the first thing that you should notice is that it looks from a distance to be very similar, and it is, but there are some very important differences. The first is, yes, there is a DNA helicase which unwinds the DNA and introduces these single-stranded binding proteins to stabilize it, but there's not a DNA gyrase. And this is because imagine the difference between a rubber band and a piece of string. If you were to twist a rubber band, it ends up supercoiling on itself. That's what a prokaryotic chromosome looks like. A eukaryotic chromosome looks like a string. And so if you twist a string in your hands and unwind it, it can just untwist itself at the other end. And so you don't need that same unwinding in order to allow replication to proceed. So that's the first thing. The second thing that you should notice is that the creation of the RNA primer and initiation of DNA replication is performed by a DNA polymerase, right? In prokaryotes, they use a very specific RNA polymerase. In eukaryotes, they have a DNA polymerase that generates the RNA primer and initiates DNA replication. That initiation of DNA replication is also different than the DNA polymerase that does the leading strand polymerization. So you have two separate sort of polymerases already involved with this process of DNA replication. We have just a different name for DNA polymerase 1. It's DNA polymerase I think that's sigma. Yes, that's sigma. Sorry. And so its job is to do the same thing that DNA polymerase 1 does in bacteria. That is removing the RNA DNA hybrids and then introducing the appropriate DNA stretches into the existing lagging strand.